Math 2, here we go. We got lesson 4.6. This is the last of the Unit 4 lessons, and we're going to do points of concurrency. Now, some of these we've already touched on, but we're going to cover it because we've got some more that we haven't done yet. So we've already done the centroid, and that's the point of concurrency for the medians. Now, the medians, remember we said, were made by finding the midpoints. So I'm going to say this is about the midpoint there. So if I connect those 2 points, and this is congruent to this, that would be a median. And then if I connect these points over here, I'm going to say right about there-ish, that's going to be another median. So this one's congruent to this one, because those are medians. And then remember we said that if we find the other median, there's the midpoint right there, and these would be the same over here, and these are the same over here. And so what we have here is this point here would be the centroid, because that's where all of the medians are coming together. So that's a centroid. So a point of concurrency is where the segments of a triangle intersect. And these median segments are all intersecting at this point. So the median goes from an angle to the midpoint of the opposite side. So that's our centroid. And we also said that the centroid does some cool stuff with it. It splits it into a 1/3 and 2/3 proportion there for the entire median. Good stuff happens. All right, the next one that we've already done was an orthocenter. And this was the point of concurrency for altitudes. Remember, an altitude went from a vertex and then traveled to the other side until it was perpendicular to that side. So I'm just eyeballing it here, so hopefully I'll get it pretty close. Yeah, that's pretty close to 90. Not my best work, but whatever. So the next one, I'm thinking, it's hard to do when you're looking this way. Yeah, that looks better. So I'm going to say, move it down a little bit right there. Yeah, let's just say that's it. So this is 90 degrees right here. And if I went 90 degrees over here, we'd get our other altitude. So all of our altitudes, they go from a vertex to the opposite side at a 90-degree angle. And then we would say, okay, that is my orthocenter right there. And we didn't do anything special mathematically with orthocenters. It's just a different point of concurrency. All right, here's one that we haven't done before. This one's called the circumcenter. The circumcenter is the point of concurrency for the perpendicular bisectors, and we're talking about the perpendicular bisectors of the sides of the triangle. So a perpendicular bisector is doing two things. It is cutting the segment in half, going through the midpoint, and at the same time, it is perpendicular. So let's find the midpoints. So midpoint, I'm going to guess, this one's a tough one. Midpoint for this one, I'm going to say is right about here. Okay, a perpendicular bisector, so it's a little bit like the centroid, where we were going to the midpoints, but it's also a little bit like the altitudes, where it's 90 degrees. It's a little bit of both. So what we notice about this is when we do it, notice that this is not going to go through that vertex. And that's okay. It just doesn't go through the vertex. It's just the perpendicular bisector. This is the same here, same here. Let's do it for the other ones. So let's see. So a little bit under 3. What am I going to do? Let's do this. 1 to 4. Yeah, right in between there. So 1 to 3 right up there. Oh, I think that's about it. All right, I'm going to call that So here I get another perpendicular line going through that one. Oh, that wasn't very perpendicular. There. I feel better about that line. All right, so perpendicular, and this side is congruent to this side. All right, last side, let's find the halfway point. So I'm just eyeballing these. I think it's going to be right about here would be halfway. And we'd get a perpendicular line going right about here. Now look what happened. If I would have done it perfectly, and I was pretty close, what happens is all of those perpendicular bisectors meet here. Now remember, these are not going to the vertices, which is different from what we had been doing. So these ones are just perpendicular and bisecting, but they have nothing to do with the angles. And that looks like that is what we call the circumcenter. Now, what's special about the circumcenter? Well, let me get my compass out. So if I did this right, this should be the center of a circle that perfectly goes around the outside of the triangle. Oh, I'm pretty good so far. See that? That center goes through that point and that point. If I keep on going, I'm pretty close. Yeah. Not bad for just kind of not really measuring. So what we would get with the circumcenter is it's the center of a circle that goes around the outside of the triangle. Now what's special about this is if I go from the vertex to that center, oops, that was supposed to be straight, you know that. And then I go right here. If I go from my vertex to the circumcenter, these are all radiuses of that circle. So these are all the green lines there. Those are all the same length because they're all radiuses of that circle that I drew. Okay, so circumcenter, it's made from the perpendicular bisectors. So perpendicular means that it's a 90-degree angle. Bisect means it's cutting it in half. Remember, it's not necessarily going to the vertices. Last one is the incenter. The incenter is made from the angle bisectors. So we're going to cut these angles in half. So let's see, where's my red pen? There's red pen. Half of the angle, I'm going to say right about there-ish. Okay, so I'm going to cut that angle in half. And again, I'm just... don't make fun of me if I don't do this perfectly right, because I'm just eyeballing at this point. Okay, I'm going to say that's cutting the angle in half, kind of. Oh well. Okay, I'm going to say right about there, that cuts that angle in half. And then I'm going to say right about, I don't know, here-ish? Yeah, right about there, that cuts that angle in half. And what do you know? Wow, this actually came out. What do you know? They all meet at the same spot. So this angle's been cut in half, this angle got cut in half, and then this angle got cut in half. So we've got angle bisectors because those angles are cut in half, and what do you know? They all meet in the same spot, and we call that the incenter. So what does an incenter do that's special? Well, it is a circle that goes inside of the triangle. And I might have made this triangle too small to actually do this. Yeah, I probably did. Oh well. We're just going to go with it and say that it makes a circle inside of the triangle. That was really bad. That's like one of the worst circles ever created in the history of circles. Pretty sure there's a history of circles. But anyways, so what this would create is a circle inside of the actual shape, if I would have done it correctly. But this is the basics. Okay, so This would be the incenter, and this would be the center of the circle that can fit inside of the shape, whereas this one was the circumcenter, which is the center of the circle that can go around the outside of the shape. Okay, so we've got 4 points of concurrency, but all I'm going to really ask you to do, besides where the centroid we're looking at the distances, I just want you to know that the centroid is made from medians and be able to say, there's the median, so that must be the centroid. And that the orthocenter is made from the altitudes and go, those are altitudes, so that must be the orthocenter. And then look at this one and go, those are perpendicular bisectors meeting there, so that must be the circumcenter. So perpendicular meaning 90 degrees, bisect meaning it's cut the side in half. And then I just need you to know that, okay, these are bisecting these angles, so that must be the incenter there. So using flashcards on this would be really helpful, where you had like the name incenter on one side, and then maybe on the other side, say that it's the perpendicular bisectors and have like a sketch of what it looks like. So you're just going to need to know those 4 points of concurrency. That's all my notes that I have for you today. Thank you for not laughing at my horrible circle that I drew down there. Okay, bye-bye.